So let's look at an example of the first one in section 3. These are non-calculator, and they're always on the exam. So they give you a shape. This is the graph of f. It says it's a continuous function, and g of x is equal to the integral of 1 to x of f of t d of t. So part A says find the values of g of 2 and g of negative 2. So you're going to come down here. G of 2 is the integral of 1 to 2 of f of t of d of t. Well, you don't have a function rule, so you're going to have to use your geometric shapes. So you're going to go up here and go from 1 to 2. And if you go from 1 to 2, you're going to look at your shape, and it's going to be a triangle, this little triangle here, and it's under the x-axis, so it's going to be negative 1/2, 1 times 1/2, because that's what this is, and you get negative 1/4. So straight from the geometric shapes that we've done before. Now, g of negative 2 is 1 to negative 2, but remember this is in the wrong order, so your integral rules allow you to switch it by putting a negative out front. So now we're going from negative 2 to 1. So we've got this triangle right here, which is 1/2 times 1 times 3, and then we've got the semicircle that is below the x-axis, that's 1/2 pi 1 squared. And so if you do that, you get pi minus 3 over 2. So part B says for each of g prime negative 3 and g double prime negative 3, find the value or state it does not exist. So this is a key on this section. G prime of negative 3, so that means the first derivative. If you go up here to the g function, remember you'll be taking a derivative of an integral, so that means it's just equal to f of x. So that means the graph of f is the first derivative of g. So when I go g prime of negative 3, it's just f of negative 3, and I go up here to my graph, and negative 3 is equal to 2. Now g double prime, I'm going to go to the point negative 3, and I'm going to do my slope formula. So I'm going to do 3 minus 1 over negative 2 minus negative 4, because I'm using those two order pairs, and I get it to be 1. Part C says find the x-coordinate of each point of the graph that has a horizontal tangent line. For each of these points, determine whether it's a relative min, relative max, or neither. So remember, that would be where the first derivative of g equals 0, so that's going to mean where f of x equals 0. And it equals 0 at x equal negative 1 and x equal 1. So you're going to look at the graph. At x equal negative 1, you're changing from positive to negative, so that's a relative max. And at 1 is neither, because it does not change signs on the derivative. Part D says find all the values of x which the graph has a point of inflection. Explain your reason. Now remember, the point of inflection is where concavity changes or the second derivative changes sign. Well, we have the first derivative graph, but remember, if the first derivative is decreasing, it's concave down on the original because the second derivative is negative. If the first derivative is increasing, the second derivative is positive, and it's concave up. So all you have to do is look and see where it changes direction. And it changes direction at x equal negative 2, x equals 0, and x equal 1. And your justification is at x equal negative 2, g prime x, which is f of x, changes from increasing to decreasing. At x equals 0, g prime x, which is f of x, changes from decreasing to increasing. And at x equal 1, it changes from increasing to decreasing. So that's your justification. Now let's take a look at the next one, which is the 2011 one. It says let g be a piecewise function, negative 2 pi to 4 pi, whose graph is given above, and let f of x equal g of x minus cosine x over 2. So part A says find from negative 2 pi to 4 pi f of x d of x. Show your computations. So it said that f of x was g of x minus cosine, so we're going to break it up. So it would be negative 2 pi 4 pi of g of x minus negative 2 pi 4 pi cosine x over 2. So on the g of x one, we're going to use the geometric shapes. So if you're going from negative 2 pi to 4 pi, it's just going to be the triangle. So it's going to be 1/2 6 pi times the height 2 pi, which is 6 pi squared. Over here, we're going to use our power rule, but we're going to have to do u substitution because the angle is 1/2 x. So if you do u equal 1/2 x, du equal 1/2. So you're going to negate it by putting 2 sine 4 pi minus 2 pi. And if you do that, you end up getting 0 when you plug all that in, 4 pi minus 2 pi. You can see the calculations here. So your final answer is just 6 pi squared. So part B says, find all the x values in the open interval of negative 2 pi to 4 pi, for which f has a critical point. So again, you're going to take the derivative of f, so that'll be the derivative of g plus the derivative of cosine pi over 2, which it'll be 1/2 sine x over 2. So we want to know so we're going to go from negative 2 pi to 0 and get our slope of this. And if you use just your slope formula, you get 1 plus the derivative of cosine over pi over 2. And then from 0 to 4 pi, if you do your slope formula here, you get negative 1/2 plus 1/2 sine x over 2. So we're going to set this equal to 0 and solve, and you won't find a value that equals 0 on that one. Here you're going to set it equal to 0, do your algebra, and you get sine of x over 2 equal 1. So remember, you ask yourself, where does sine equal 1? It equals at pi over 2 and 5 pi over 2. And so you multiply by 2, and you get x equal pi within that interval. You also get x equals 0 because at 0, f of x doesn't exist, because see how your slopes are different at 0. So your answers to part B are x equals 0 and x equal pi. Part C says let h of x be 0 to 3 of x, g of t of d of t. Find h prime of negative pi over 3. So if h of x is that, then h prime, remember by second fundamental theorem of calculus, it'll just be g of 3x. But if that top interval is not x, you have to multiply it by the derivative of that. So it'll be 3g of 3x. So if I plug negative pi over 3 in, I get 3g of 3 times negative pi over 3, which is 3g of negative pi, which is 3 pi. Now let's look at the next one. It gives you a graph. It says this is the graph of g prime. G is defined on an interval from negative 7 to 5, and g of 0 equal 5. Remember, that's important because that's going to be a startup point. And it consists of a semicircle, 3 line segments. So it says find g of 3 and g of negative 2. well, you always start with your starting point. So you say g of 3 equals 0 of 0 plus 0 to 3 of g prime t. So we know that's 5, and then we're going to go from 0 to 3 in our geometric shapes. So that'll be 1/4 of a circle, which will be 1/4 pi, 2 squared, plus this little triangle, half of that big triangle, which will be 1/2 1 times 3. If you put that together, you get 13 halves plus pi. Now, g of negative 2 equals g of 0 plus 0 to negative 2. Well, remember, we got to switch the integral order. So it'll be g of 0 minus negative 2 to 0. So that'll be 5 minus our little quarter circle, and we get 5 minus pi. So again, you're using your starting point and then just your geometric set shapes. Part B says, find the x-coordinate of each point of inflection on the graph on the interval of negative 7 to 5. Explain your reasoning. Okay, so remember, the point of inflection is going to be where the first derivative changes direction. Well, this is the first derivative graph, so it changes at x of 0, x equal 2, and x equal 3. At x equals 0 and x equal 3, it changes from increasing to decreasing. And at x equal 2, it changes from decreasing to increasing. So that's your justification that you explain it. C, it says the function h is defined by h of x equal g of x minus 1/2 x squared. Find the x-coordinate of each critical point of x and classify it as a relative min, relative max, or neither. Okay, so if we take the derivative of h, it'll be the derivative of g, and if you do the power rule here, it'll be minus x. And you set that equal to 0, so that means you're looking for where g prime of x equal x. And where does that happen? At x equal 3, because you see you have 3 equal 3. So, and that's neither, because it's not changing from positive to negative or negative to positive. Now, here's a part, and I think we had this one before, and I'm not sure you would have gotten it, but there's also square root of 2 where it works, because this is a circle. You've only got the positive part of the circle, but the equation of the circle is y squared equal 4 minus x squared, because it started out at x squared plus y squared equal 4, because the radius was 2. So if I solve for y, I get that. So if x was square root of 2, and you plug that in, look what you get. Y equals square root of 2. So square root of 2 equals square root of 2. Now, think about that. If you were talking about the g of x being square root of 2 minus square root of 2, it's going to drop this graph down by square root of 2. So I've kind of sketched it down here if you can look at it. So it's really going to change from what? Positive to negative when it drops down. So that means that square root of 2 would be a max. But if you only got the part 3 of 3, you would get one of the 2 points.